Welcome to Lecture 17, Unit 3. This is Probability Distributions. My name is Jorge. So what we're going to do is we're going to go ahead and learn how to construct a probability distribution from a random or for a random variable. And so just a quick review, a variable was defined as a characteristic or an attribute that can assume different values. We use capital letters, X, Y, and Z to represent the variables. So in this lecture, what we're going to talk about are variables that are associated with probability, and these are what we call random variables. So if a die is rolled, a letter such as X can be used to represent the outcomes. Then the value that X can assume would be 1, 2, 3, 4, 5, or 6. So a random variable is a variable whose values are determined by chance. Now, if you remember, discrete variables have a finite possible values, or an infinite number of values that can be counted. So when we say counted, we mean 1, 2, 3, 4, 5. And discrete variable would be number of siblings, right? Either 0, 1, 2, 3. You can't have a 0.5 sibling. So now, variables that can assume all values within an interval are what we call continuous. Now, continuous random variables are obtained from data that can be measured rather than counted. So let's go back to discrete probability. So a discrete probability distribution consists of values a random variable can assume, and then the corresponding probabilities of those values. Now, the probabilities are determined theoretically or through observation. Now, discrete probability distributions can be shown using a graph or a table. So here's an example of rolling a die. So we're going to construct a probability distribution for rolling a single die. So the outcomes that we have for when we roll a die is 1, 2, 3, 4, 5, or 6. Well, what's the probability of rolling a 1 or rolling a 2, or 3, or 4, or 5? Well, it's 1, 6. So the probability distribution for rolling a die is illustrated in this table. So the probability that we get a 1 is 1, 6, a 2 is 1, 6, and so on. Now, if we toss 5 coins and then observe the number of heads that are visible, what values may the random variable X take on? So the values would be 0, 1, 2, 3, 4, or 5. We can get 0 heads, 1 to head, 2 heads, 3 heads, 4 heads, or 5 heads. So what's the probability of each outcome? Well, there are 32 possible outcomes. And actually, if you do a tree diagram, you would end up with the 32 possibilities. So there's only one way, so 1 out of 32 to get 0 heads, or 1 out of 32 to get 5, or 5 out of 32 to get either 1 or 4, or 10 out of 32 to get 2 or 3. Now, this formula here in the bottom is the binomial formula. And later on in the course, we'll actually learn how to use this formula, and we can actually calculate this without constructing a tree diagram. So here's another example. The Baseball World Series is played by the winner of the National League and the American League. And the first team to win 4 games wins the World Series. So the World Series can consist of anything between 4 games to 7 games. So let X represent the number of games, and then we're going to find the probability, P of X, for each X. And then we're going to go ahead and construct a probability distribution and also construct a graph for the data. So here's X, so 4, 5, 6, 7 games. Those are the possibilities. So those are the possible values that this random variable can assume. Now, out of the last 40 World Series, 8 of them went 4 games, 7 went 5, 9 went 6, and then 16 went 7 games. So then the random variable X can assume values of 4, 5, 6, or 7. So the probability of each then would be 8 out of 40 for 4, 7 out of 40 for 5, 9 out of 40 for 6, or 16 out of 40 for 7. And then graphically, that's what it looks like. So this is the probability distribution for 40 World Series tournaments. Now, probability distribution can also be written in a formula such as P of X is equal to 1 over X, where X can take the values of 2, 3, and 6. So the values for X that can take are 2, 3, and 6. P of X will just be 1 over X, which it's either X going to be 2, 3, or 6. So we can go ahead and calculate the probability for each one. So then there are 2 requirements for a probability distribution. The first one is the sum of the probabilities of all events in the sample space must equal 1. So the summation of P of X has to equal 1. And the probability of each event in the sample space must be between 0 and 1. And that's the end of Lecture 17, Unit 3. Thank you.